All right, guys. We have, y'all have the note sheet, yes? So, we have officially finished chapter 1, and we're moving on to chapter 2. Now, now with chapter 1, if you noticed, probably that from section to section, it jumped around a lot from what we talked about from section to section. It was a very broad subject area that we covered from one to the next. Now, luckily for chapter 2 and chapter 3, well, for the rest of the chapters, it's going to be very more condensed. We're going to single out a specific topic and cover those in each one. So with chapter 2 and 3, we're going to be talking about quadratics, purely talking about quadratics and their properties and kind of dealing with those properties of them, solving, going with this here. Chapter 2 is going to deal mostly with properties of quadratics. We'll deal a little bit with solving, but we'll dig more into solving and ways to solve quadratics in chapter 3. But this is mainly going to focus on quadratics. Now, we consider a function to be, or a polynomial function to be quadratic is our x squared. X squared is going to be the variable, well, 2 is going to be the biggest exponent we have attached to a variable. That's the quadratic term. Because we can have a plus x as a part of a quadratic, the x to the first power is our linear term, because x is a linear. If we just had y equals x, it's a line, equation of a line. That's the linear part of it. And we can have a constant term too, but since x squared is the variable with the biggest exponent, it's a quadratic. If we had x cubed, x to the third power, it wouldn't be considered quadratic anymore. It would be considered cubic, because it's defined by the variable with the biggest exponent. So with any of these here, x squared and x inside of a parenthesis squared is as big as these will get, because they are quadratics. Now the first thing we're going to look at is transformations, moving it up, down, left, right, stretch, shrink, and reflections. We're doing these again. Now, we'll look at this first part here. Now there's 3 parts to it, A, H, and K, and these are stuff that we've covered already. So you can write these down if you want, you don't have to. Now the A has 2 main parts. If A is negative, it's a reflection across the x-axis. If it has a value between 0, 1, and greater than 1, it's a vertical V-E-R, I think I spelled that right, V-E-R-I-T-A-L. C-A-L. I knew I was missing something. Vertical stretch slash shrink. Because it's going to be a vertical stretch or shrink. I only paused because I was still trying to figure out how to spell vertical for a minute. I've been spelling it all day. V-E-R-T-I-C-A-L. I needed to switch the T and I. V-E-R-T-I-C-A-L. Vertical. Vertical stretch or shrink. Now the next part we have is the H. H is our horizontal translation. This is moving it to the left or to the right. Our horizontal translations is moving to left or right. And we've done those before, those I's of H. Because we did those there inside the parentheses is the opposite of what we think. And lastly, our value of K is our vertical translation. This is our up or down. And we've done these already. We've worked with these before. So we kind of see these, get these. Now, the first two we're going to look at is horizontal and vertical translation. Inside the parentheses are x minus h. If h, the value of h, is less than 0, it shifts to the left. Shifts to the left. If h is greater than 0, it shifts to the right. And that's kind of what we have down here. Now, again, this is purely talking about the value of h itself. So if I said that we had x minus 4 squared, what is the value of h? 4. Because our general form of this is x minus h squared, yes? So we do have the x, we have the minus, h is indeed 4. Since 4 is greater than 0, it's moving it to the right. 4. And if we had x plus 4 squared, in this case, what's the value of h? Negative 4. Because this is really saying x minus 4 squared, that's where we get that. Because we can try keeping that in mind and kind of doing it that way. I still think that's a little bit much to try to keep straight with everything else that we do with these transformations. I think the easiest way to go about these inside parentheses is the opposite of what we think. So x minus 4, negative. It looks like it should be left, but it's actually going to the right. X plus 4 looks like it should go to the right, but it's going to the left. Now, vertical translations up or down. That's exactly what it looks like. If we add 4 to it, it's moving it up. If we subtract 4, it's moving it down. So let's look at these first ones here. Describe the transformation of f of x equals x squared. I gave you guys the graph. By g of x equals x plus 4 squared minus 1. Now we have two transformations. We have the x plus 4 inside the parentheses, and we have the minus 1. So what's one of our transformations? So do we want to look at the x plus 4 inside the parentheses or the minus 1 first? Minus 1. Which direction is that moving us? Left or right or up and down? So horizontal left and right is inside. Up and down vertical is outside. So our minus 1, is that inside or outside? It's outside, yes? So we're talking about up and down. Now up and down is exactly like we see it. So since it's minus 1, it is indeed down. How far? Down 1. Minus 1 is going to move it down 1. Now the plus 4 inside the parentheses is going to move it to the left or to the right. Inside parentheses is the opposite of what we think it is. So since it's plus 4, it makes it look like it's going to the right, but it's actually going to the, so this would be left 4. Questions on this here? Now, we'll definitely get to these here, and especially graphing them, how to plug these into the graphing calculator. But this here, the blue graph is x squared. That's the parent function. Now, our new function, inside the parentheses, we have x plus 4 squared, yes? And we said this plus 4 is moving it 4 units to the left. If I tell it to graph it, well, the red graph indeed did move 4 units to the left. Now, our function did have one other part. It had what? -1, which means it should also move it down 1. It did move it left 4 and down 1. And it does that with every single point. Questions on this here? Now the second part of this says then graph each function. We're not going to graph it. I'm not going to have you graph it. And it's not because there's no point in graphing it, but we have so many utilities to graph. There's not a whole lot of reason to know exactly how to graph it by hand. The biggest thing is with any of this here is that you have an understanding of how the function should look, what it should look like. We can see a quadratic, our U-shaped graph at the center. Okay, it's moved down, over and down. Because if I wanted to do it by hand, well, this point 0, 0 has moved 4 units to the left and down 1. At 1, 1 moved 4 units to the left and down 1. Negative 1, 1, over 4 and down 1. 2, 4 is moved 4 units, 1, 2, 3, 4, and down 1. 1, 2, 3. And we could do the same thing with negative 1, 4, or negative 2, 4. And we get these points here, which give us a U-shaped graph. There's our new parabola. But I'm not going to ask you to graph them. I'm just asking for the transformation. So let's look at the next one. Well, how many transformations do we have here? We do have one, because we just have the x minus 3. We don't have anything added or subtracted outside the parenthesis to it at the end, so it's not moving up or,
so it's going left
or right. So it would be right 3, because it's the opposite of what we think, because it does indeed look left because of the negative, but opposite of what we think. So it's going to be moving to the right, right 3. Questions on this here? We're ready for the next one. Ready to see another one of these. How many transformations do we have here? 2. Because we have x minus 2 inside the parentheses and negative 2 outside.
so if it's right 2.
Exactly.
And then the negative 2 is going to be
Yeah, so inside the parentheses is our left or right, opposite of what we think. So it's going to be right 2, because again, that minus makes it look like it should be left, but it's right. Down 2. Yes. Because down is our negative direction, so it takes care of that too. Yep. Right 2, down 2. And every point on this graph would go right 2, down 2, right 2, down 2. And then we get our quadratic. So we don't have to worry about graphing it, because again, I could take the graphing calculator. There we go. Because I could say x minus 2 minus 2 graph, moved it right 2, down 2. Questions on this here? Let's look at the next one. X up 1, yes. How many translations are there? 2, yes. So up 1 is one of them. What's the other one? Because the x plus 5 inside looks like it should be right, but it's actually left because it's the opposite of what we think. So left 5, up 1. And that's it. Questions on this here? We're ready for the next part. How about our 2 transformations here? So we only have 2.
Oh. Right. I was looking at that.
Yes. Right 1 and up 2. Because it's really saying f of x equals x squared is the parent function. What do we do to it to get to our new one? What did we do to it to get to x minus 1 squared plus 2? Well, we moved it right 1 and up 2. Questions on this here? We ready for the next one? Well, that moves us actually into our next transformation. Reflection. So if we have a negative in front of x squared outside the parentheses, it's a reflection across the x-axis. If it's in front of the parentheses or in front of x squared without parentheses, reflection across the x-axis. Now, if it's inside the parentheses in front of x, it's a reflection across the y-axis. Now, as it says here, negative x in parentheses squared is the same as x squared. Well, that makes some sense because negative x times negative x. Well, our x times x is indeed x squared, yes? What's a negative times a negative? So it's just x squared. And part of the reason for this is that every point on the left side of the y-axis, when we reflect it across the y-axis, actually lands on every point on the right side. And every point on the right side will land on the left. So it's reflected onto itself. We don't have a change. Does that make sense? But if we have, say, x squared, not x squared, x minus 1 squared, this is not the same thing as negative x minus 1. Or if I had negative x minus 1, I can't just drop the negative off of it and get the same function. Those are two different functions. Does that make sense? This being able to remove the negative only works if x, negative x, is by itself. This is also, I mean, if we had negative 4 in parentheses squared, that works because negative 4x times negative 4x. Negative 4 times negative 4 would be a positive 16. Then we could simplify it. But if you left it as, say, negative 4x squared, I'm not going to mark it wrong. That is perfectly fine. That is a correct answer. Questions on this here? Okay. Now we do have two other types of transformations with this. Horizontal stretch and shrink and vertical stretch and shrink. Let's look at vertical first. Ax squared. When we have that a in front of the parentheses or in front of our x squared without parentheses, it's a vertical stretch or shrink. If the value of a is greater than 1, it is a stretch. If it's between 0 and 1, it is a shrink. These we get. These are nice. Because if the value of a is greater than 1, it's a stretch. If it's between 0 and 1, it's a shrink. Now, horizontal is where, again, the value of a, if you notice, is inside the parentheses. It's in front of x being multiplied, but it's inside parentheses. And at the bottom, it says horizontal stretch away from the y-axis when a is between 0 and 1. That's the opposite of vertical stretch and shrink, yes? Because for vertical stretch and shrink, we're saying a is greater than 1. Opposite of what we think. So a horizontal stretch is between 0 and 1. A horizontal shrink is greater than 1. Opposite of what we think. And again, when we talked about applying horizontal stretch and shrink, we had to flip it, yes? Still have to do that here. Now, talking about the definitions finding good, let's actually look at some, because I think it's easier to understand when we look at some example problems than it is to just explain definitions. So g of x equals negative 1/2 x squared. How many transformations do we have here? It is 2. Because we do have the negative and we have the 1/2. The negative, negative is attached to A. Negative and 1/2 are both attached to A. But which of our transformations purely talks about negatives? Stretch and shrink, these are all between 0 and 1 and greater than 1, yes? Reflections is just negatives. So here, the negative in front of the 1/2 is a yes. Now, it's a reflection across the x-axis because the negative is outside parentheses. Now, if there are not parentheses put in, if there are no parentheses, it's automatically understood to be outside. If they're not included, it's understood to be outside the parentheses. Because if I were to write them in, it would look like this here. We would have the parentheses strictly around the x, but there's no real reason to put them there. Questions on the reflection part? So that leaves us with the 1/2. Since it's being multiplied by x, it's a stretch or shrink. Now the question is it horizontal or vertical? It is vertical because vertical is outside parentheses, horizontal is inside. Because if we look at these two here, horizontal stretch and shrink, the A is being multiplied by x inside. Vertical, it is outside. So it is vertical. Now is it a stretch or shrink? And that's it. Because vertical stretch and shrinks exactly like it should be. If it's greater than 1, it's a stretch. If it's between 0 and 1, it's a shrink. The negative on this is not talking about the stretch or shrink. It's talking about a reflection. Questions on this here? Let's look at the next one. Now, realistically, I didn't say this on the last one, but whenever we do these here, always label left, right, up, and down first, describe them first, then reflections and our stretch and shrink. So here, the +1 on the outside would be moving us where? Up, down, left, or right? Outside is where? Up and down or left and right? Yes. Inside parentheses is left and right. Outside is up and down. Up and down is exactly like we think it should be. So +1 should be. So this is moving up 1. Yes. Now the other one is our 2. 2 is being multiplied by x, yes? So is it horizontal or vertical? Horizontal because it's, yes. So what does it look like it should be? Looks like it should be a stretch, yes? Since it's inside the parentheses, it's the opposite of what we think. So it's going to be a horizontal shrink of what? Almost 1/2. Got to flip it. Like when we plugged them in, how we had to flip the value when we plugged it in, the same thing as when we pull it back out. Now, I think it'll be helpful to go back to this one here. When we talk about vertical stretch and shrink, I'm going to come back to this one here in a minute. Vertical stretch and shrink. Vertical is up and down, yes? So if it's a vertical stretch, it means it's going to increase faster along the y-axis. So it's going to look skinnier because it's increasing faster in the y. So for this here, the one we have -1/2 x squared, I'm going to just say 1/2 x squared is a vertical shrink, which means compared to the original function, it should be increasing slower along the y-axis up and down vertically, which means it is wider. If the y values are increasing slower at a slower amount. If we said it was 2x squared, this would be a vertical stretch, so it should be increasing faster than the original one, so it'll be skinnier. Now, the one we just had was 2x squared, we said was a horizontal shrink, which means horizontally, left and right, it should be increasing slower than the original one. And if we graph it, it is indeed increasing slower along the x, yes? It does seem similar to a vertical stretch, but it's not a vertical stretch of 2. It actually would be a vertical stretch of 4. And there's more to it, but we're not going to delve into why too much. Because if I did 2x squared, we can see the one in red is actually increasing faster. But that's neither here nor there. Now, if I'd have said 1/2 x, so again, 1/2 looks like it should be a horizontal shrink, yes? It's going to be a stretch, yes? So it should be increasing faster along the x horizontally. And it is increasing faster horizontally, yes? That's why we kind of have that flip. And I think seeing that graphically does help us kind of distinguish why it's flipped, yes? Okay, let's look at the next one, negative 3x squared. Do we have a left or right movement? Do we have something inside parentheses being added or subtracted from x? No, so we don't have left or right. Do we have up and down? Yeah, because if we had up or down, it would be plus a value, yes? Do we have that? No, so there's no up and down, there's no left and right. So there is a reflection. I will, because the negative is talking about a reflection. Is it inside parentheses or outside? It's outside. There are no parentheses, so it's automatically outside. If it was inside, it would be across the y. Yes. Since it's outside, it's going to be across the x-axis. The negative part of A tells us a reflection. The 3 tells us it's a what? Stretch of 3. Since there are no parentheses, it's automatically understood to be outside. Questions on this here? Let's look at another one. 1/4 x squared minus 2. So again, the ones we really want to start out with are kind of the easier ones, up, down, left, right. Do we have a left-right movement? No, we don't have something added or subtracted to x inside parentheses, so there is no left-right. Is there an up and down? Okay, how far? Outside of parentheses, exactly what it looks like. Since we have minus 2, it is indeed moving down 2. So we took part of the negative 2. The only thing we have left is the 1/4 in front of the x. So reflections are purely negatives in that spot. So 1/4 is not negative. It is horizontal, stretch or shrink, because we have it multiplied in front of x inside parentheses. Now, it looks like it should be a shrink. Exactly, so it should be a horizontal of 4, because we've got to flip it. So the only one we have to actually flip is stretch or shrink with horizontal. Left to right, we already take care of kind of the opposite of what we think it is. So we get this here. Questions on any of this so far? We ready for the next one? What would this one be? Horizontal stretch of 3. Since the 1/3 is being multiplied by x inside the parentheses, it's horizontal stretch or shrink. Opposite of what we think, so it looks like it should be a shrink, but it's actually a stretch. Flip the 1/3 to give us our actual value of 3. Now, we good with this here? Now, it doesn't have to be 1/3 always with a 1 on top. We could say 2/3 x squared, which would flip to 3/2. Does that make sense? Yeah, because we're just flipping it. In all these cases, the numerator's been 1, so when we flip it, 2/3? I just picked it. So let's look at this next one here. 3 times x minus 1 squared. Let's deal with up, down, left, right first. Is there an up or down movement? No. No up and down, so is there a left or right? Yes. Right? 1. Vertical or horizontal? Right, the 3 is not inside the parentheses, is it? Or is it outside? So outside multiplication like that is vertical stretch or shrink. Vertical. Now, since the number is greater than 1, it is a of 3. If it had been parentheses 3x, then it would be horizontal shrink of 1/3. Now again, the negative in one of these two spots, in front of the x or in front of the 3 here, would have been a reflection. Questions on this here? How many transformations do we have here? 3, because we have the negative in front of the parentheses. We have the plus 3 and 2, yes? Again, deal with left, right, up, down first. So do we want to deal with the plus 3 inside the parentheses or the plus 2 outside?
Let's do the plus 2 first.
Plus 2 is vertical, up, down. Exactly what we think it is, so up 2.
And then that would be horizontal, so it's going to go left.
Yes.
And then reflection.
Right, so the plus 3, opposite of what we think, so left 3. The negative, again, in front of the parentheses or in front of x is purely reflection. Since it's outside the parentheses, it's across the x-axis. If it's inside the parentheses in front of x, it's across the y-axis. Are we starting to get the hang of these? And this is not just, I'm looking at it and based off each one, I'm looking at where those things are located. Because the plus 3 is located where h is. And normally I'm referencing back to those. I didn't actually reference those all day. But that plus 3, that's where our left, right is located. The plus 2 is where our up and down is located. The negative is where a is, that's reflection. If it had been inside the parentheses here, that's where reflection in y is. So it's purely where is it located in the function? What is it doing to it? Questions on any of this here?